All right, in this algebra video, we are going to go over piecewise functions and how to evaluate them at different values of x. So piecewise functions are functions that have different function rules over different intervals of the domain. So it is easier than it sounds, trust me. All it means is that the function rule that you use to find out what y is not going to be the same throughout the whole function. It depends on what x is. All right, so let's look at what that looks like. The piecewise function f of x is given below. So this is a problem from the Algebra 1 Regents in New York a few years ago. So we're given the function f of x, and we're not just told that it equals 2x minus 3 or that it equals x squared, but that it equals these two different expressions depending on what x is. So the way that we read this is that f of x is equal to this, 2x minus 3, if x is bigger than 3. So anytime you're given an x value that's bigger than 3, you're going to use the expression 2x minus 3 to find out what the corresponding y value or f of x is. However, if the x value is less than or equal to 3, then f of x is going to be equal to negative x squared plus 15. So when I say different intervals of the domain being all your possible x values, it depends on what the x is. You have to know what the x is first. That'll tell you which rule to follow, and then you'll find y. All right, so let's go ahead and go into this example. This example is asking us to state the value of f of 3. So first we have to see, okay, where does 3 fall in terms of our rules that we're given? So we have two different rules here for this function. One of them if x is greater than 3, and the other if x is less than or equal to 3. So if we're trying to find f of 3, that means we're going to have to follow the blue rule because 3 is less than or equal to 3, but 3 is not greater than 3. So we can't follow that purple rule that I circled up top. All right. Once you know what rule it is you're following, all we're doing is evaluating at that specific x value. So I'm going to write down the rule that's appropriate for this x value, negative x squared plus 15. And we're just going to carefully substitute in here. So f of 3 is going to be equal to negative 3 squared plus 15. Now at this point, you can grab your calculator and just throw this all in here, or we can do it by hand. So I have negative 3 squared is 9 plus 15, f of 3 is equal to 6. So that tells me that in this piecewise function, when my x value is 3, my y value is 6. So that 3, 6 is an ordered pair on this piecewise function. All right. Now, if we did a different x value, let's say, for example, they asked us to find f of, what was my rules again? If they wanted f of 5. All right, so if you want to find f of 5, looking back at our two rules again, we don't know which one of these two to follow until we figure out where that x lands. So x of 5 would now land in this top expression because 5 is greater than 3. So that means we'd be following the top rule instead. So f of 5 is going to be equal to 2 times 5 minus 3. So I just replace the x with 5 in this case. And now again, we're just going to evaluate. So either grab your calculator or do this by hand. 2 times 5 is 10. I bring down my minus 3. F of 5 equals 7. So that 5, 7 is a point on this piecewise function. All right, let's do one more example. So we have the piecewise function is written in green. F of x is equal to the absolute value of x if x is less than negative 1, or it's equal to x over 2 minus 3 if x is greater than or equal to 2. So in order to find the red value, f of negative 4, we have to first determine, okay, where does that lie? Which rule are we going to follow? So negative 4, does it follow the top rule? Does it fall into this inequality? Is negative 4 less than negative 1? Or is negative 4 greater than 2? Well, negative 4 is less than negative 1, so we're going to follow that top expression and evaluate absolute value of x. So I'm going to replace x with negative 4. The absolute value of negative 4 is positive 4. So f of negative 4 is positive 4, meaning that negative 4, 4 is a point on this piecewise function. And last one, if you're asked to find f of 6 for that same function, so now we look and see, okay, which part are we following? F of 6. So when x is 6, where does it fall? Well, 6 is greater than 2. So that means we're going to follow the bottom rule this time. So now for f of 6, we're following Let's do this in blue. We're following x over 2 minus 3. And now again, we just evaluate. So we're going to replace that x with 6, right? The value that was in here. Over 2 minus 3. So 6 divided by 2 is 3. 3 minus 3 is 0. So f of 6 equals 0, meaning that 6, 0 is a point on this piecewise function. All right, so quick review. You look at the function rules that are given. You look at the x value that you're given, and you determine where does that x value fall, in which inequality. Once you figure out where it belongs, you just follow that rule. So you evaluate that expression for that given x value. And that is how you evaluate piecewise functions.